Repository pattern. Where does data come from? Network, database, cache. The UI should not care. A repository abstracts data sources. Today we understand the repository pattern and how it fits in Android architecture. A repository provides data to the application. It hides where data comes from. Network, database, in-memory cache. The caller just asks for data. The view model calls repository.getUsers. It gets users. It does not know if they came from network or cache. This abstraction is powerful. Change the data source. The caller does not change. Just with fake data, the caller does not change. Repository is the boundary between data and domain. Separation of concerns. View model manages UI state. Repository manages data. Each has one job. Testability. Replace the repository with a fake in tests. No network needed. No database needed. Fast, reliable tests. Flexibility. Start with network only. Add caching later. The view models not change. Single responsibility. Data fetching and logic in one place. A repository can combine multiple data sources. Network for fresh data. Database for persistence. Cache for speed. But there is one source of truth. Usually the database. Fetch from network, store in database, UI reads from database, UI reads from database. The database is the source of truth. Why? Network is unreliable. Cache can be stale. Database is the reliable source. UI observes the database. Network updates the database. UI sees updates. Define a repository as an interface. Interface user repository brace. Suspend fun, get users, : list of user, suspend fun, get user, ID int, : user fun, observe user, : flow of list of user, calls brace. The interface declares what data is available, not how it is fetched. Implementations can vary. Network user repository, fake user repository, forget user repository, fake user repository. Depend on the interface, not the implementation. This enables flexibility and testing. Repository functions are often suspend functions. Suspend fun get users : list of user. Fetching data takes time. Suspension makes it non-blocking. For one-time requests, use suspend functions. Fetch user by ID, create a new item, delete. For observable data, return flow, fun observe users : flow of list of user. UI collects, receives updates. The repository handles the async nature of data fetching. Callers use suspend or collect. A simple repository implementation. Class, user repository implot to constructor, API, user API, DAO, user API, DAO : user repository. Get users, try to fetch from network, store in database, return from database, fallback if network fails, return cache data from database. The implementation decides the strategy. The interface stays simple. More complex strategies are possible. Check cache age, fetch in background, sync periodically. Cache first, check cache, return if valid, otherwise fetch. Network first, always fetch, update cache, stale while revalidate, return cache immediately, fetch in background, update when ready. Offline first, always return cache, sync when possible, choose based on your needs, freshness requirements. Offline support, performance. The repository encapsulates the strategy. Callers are unaware. Repository sits between model and data sources. UI talks to view model. View model talks to repository. Repository talks to API and database. Dependencies point inward. Repository does not know about view model. API does not know about repository. This layering makes each component testable and replaceable. Compound, compose to view model to repository to data sources. Let us summarize. Repository abstracts data sources from the rest of the app. It provides a clean API. Callers do not know where data comes from. Single source of truth keeps data consistent. Use suspend functions for one-time operations. Use flow for observable data. Repositories enable testing, flexibility, and separation of concerns. Define interface, implement with real sources, test with fakes.